Grab bag number 6. Here we go. So we've got the indoor physical fitness room consisting of a rectangular region. Let's see. So I've got my rectangular region with a semicircle on each end. All right. Well, there's my pretty picture. If the perimeter of the room is to be 200-meter running track. Okay. So the perimeter is a 200-meter, and that's for the running track. So that 200 is around the whole thing. Find the dimensions that will make the area of the rectangle region, so the area of the rectangle, as large as possible. So I want the area of the rectangle to be a max. All right, so I can figure this out. If I look at my rectangle, I can label that X and Y. Therefore, the area of the rectangle is going to be X times Y. Now, once again, I've got the two variables, which is the problem. So let's try to find a way around it. The perimeter is 200. That was given to me. There must be a reason it was given to me. So I need to figure this out. If I were to find the perimeter of this track, I'd have this side and this side. So that's going to be a 2x plus. If I'm going around, here's a semicircle and here's a semicircle. Put them together, you have a full circle. How do you find the distance around a circle? That's circumference. That's pi times diameter. Well, in this case, what is the diameter? It's y. So that's just pi times y. If I sub in, 200 is equal to 2x plus pi y. Let's just solve this for y. 200 minus 2x divided by pi is equal to y. Now we can take that value right there and substitute it into my formula. Area is equal to x times 200 minus 2x over pi. Now, since I'm trying to maximize the area of the rectangle, I'm going to want to take a derivative of this formula. Let's simplify as much as possible. If I distribute 200x minus 2x squared all over pi. Now what I want to do is I'm going to split my fractions. Area is equal to, if I split that right there, that's just 200 over pi times x. Minus, if I look at the next one, I've got 2 over pi x squared. So now I know we've had trouble with this in the past. Just look at that 200 over pi. That's the same thing as 200x divided by pi, but when I write it like this, I think it's easier for you guys to see 200 divided by pi is just a coefficient. So let's take a derivative. The derivative right here. Well, the derivative here, since that's a coefficient times x, the derivative is just 200 over pi minus, well, what's the derivative of x squared? 2x. So that's going to become, let's see, if I bring the 2 down in front, 4 over pi times x. And I want to know, when does my derivative equal 0 or d and e? Well, since my denominators are always pi's, I don't have to worry about the d and e. When does it equal 0? Well, if I have that equation set equal to 0, let's add your fraction over. 200 over pi is equal to 4x over pi. Since I have the same denominator, 200 is equal to 4x, so 50 is equal to x. Now, I think if x is 50, that will maximize the area of the rectangle in this problem. I want to verify. Second derivative test. If I look at a double prime, what you want to do, keep an eye on the first derivative, and that's what I'm taking the derivative of. The derivative of 200 divided by pi, that's 0, because 200 divided by pi is a constant. Now, if I take the derivative of this, negative 4 over pi x, it's going to be negative 4 over pi. So now, if I look at that second derivative, there is no x. The second derivative is always negative, therefore it's always concave down, definitely giving me a max. So now I know that when x is 50, that will absolutely be a max. So what's the question asking me to find? The dimensions of the rectangle. So now I know that x is going to be 50, and I know that y is equal to 200 minus 2x, which is 50, over pi. Running out of space here. So therefore, y is equal to 100 over pi meters. There's my answer for y, and x is equal to 50 meters. And you're all set with problem 6.